Welcome to Animated Science Chemistry. This time we're actually going to look at the periodic table and why it's organized the way it is, and also the valence electrons and why those are probably the most important thing that you'll learn for the rest of the chemistry course. So last time we took a look at the Bohr structure of the atom and got a foundation set for the subatomic particles that are going to be making up the atoms of the elements. Quick review for that: the protons are positive and they are in the nucleus. The neutrons are neutral and they are in the nucleus as well. And then the electrons are going to orbit around the nucleus in electron shells. So let's take a look at this periodic table. The periodic table does a lot of really good things for us. It organizes the elements in a really nice way that allows us to predict their properties. So we're going to take a look at a lot of different fundamentals of the periodic table, but the first thing we want to look at is that each element, like we said last time, is going to have a different atomic number, which means it has a different number of protons. So the periodic table is going to align these in order of their atomic number, and so it shows us every single element according to their number of protons. So changing the number of protons changes the elements. However, changing the number of neutrons are going to create isotopes of the elements. So an isotope is an element with a different number of neutrons than it normally would have. So usually we find most of the elements are going to have an equal number of protons and neutrons, because that's going to create a stable element. However, that's not always true. We're going to have varying amounts of isotopes of the elements. So sometimes we may have one or two more neutrons, and that can still be a stable atom. So again, isotopes are elements with a different number of neutrons, but these guys are going to have some different properties. So when we start putting in too many neutrons, or these ratios get out of place, these elements are going to start to become very unstable. So one really good example of that is carbon-14. Carbon-14 is a pretty important isotope for us, but really what carbon-14 means is that it has a mass number of 14, which means it's got 6 protons, because it is carbon. Carbon always has 6 protons, and then if you take 14 minus 6 is equal to 8 neutrons. So carbon-14 has 8 neutrons compared to carbon-12, which is 6 protons and 6 neutrons. So in addition to neutrons, elements can also have a varied number of electrons. So usually when elements have changing number of electrons, this is going to create a charged particle. Because if we have a different number of electrons to the protons, this is going to be a non-neutral atom. And so a particle that is charged is defined as an ion. For example, if we were to look at magnesium, magnesium has 12 protons because its atomic number is 12. So its neutral state would have 12 electrons. If it were to somehow lose an electron, we'll talk about how that would happen in the next video, then it would become positively charged because it would have more protons than it would have electrons. So that's an example of an ion. Now, one thing that we need to note is that to create these ions, usually it's only the electrons within the valence shell. And so that's another new term that we need to know. The valence shell is the outer shell of the electrons. So this valence shell is very important, especially for ions, but also for most of our other chemical reactions that's going to happen. Okay? So the valence shell of the atom is usually where we have changing number of electrons, and this is also where we're going to see bonding take place. Okay, so this is also another very important aspect for the rest of the course, because most of our bonding is going to be observing the valence shell electrons. So another thing the periodic table does for us as far as the electrons go, it tells us how many valence electrons the element has. And so that's the number of electrons in the outer shell. So let's look at lithium. So lithium is in group 1A, and so that means it's going to have one electron in its valence shell. Moving over to beryllium, we see that an electron was added to that valence shell, and it's got 2 electrons in its valence shell. And notice how that's right underneath group 2A. Move over to boron. Boron's got 3 electrons in its valence shell. Carbon, 4. Nitrogen, 5. Oxygen, 6. Fluorine, 7. And neon, 8. And all of those correspond to their groups. And so those groups are going to tell you how many electrons are in their valence shell. Now this pattern of electrons in the valence shell is going to be true for those that are in group 1A through 8A. When we start talking about the metals and the transition metals that are in the middle of the periodic table, things get a little weird to the point where we can have up to 18 or even 32 electrons in their outer shells. And so that's where we need to go to the more advanced model to understand what's going on there. And the last exception to this rule is helium, because helium is in the first period. It has one shell. So in the first shell, there can only be 2 electrons in the first shell. So if we look at all of the atoms, that's going to be true of all of the atoms. The first shell can only hold 2 electrons, while the shells outside of that can hold more. So next time we're going to talk about the magic number 8 and why the next couple of shells are going to be able to hold 8 electrons, and that's going to be really important for our bonding. So another thing the periodic table does for us as far as the electrons go, so one characteristic that it does is it organizes elements into periods, which are the rows that we see, and these periods are going to tell us the number of electron shells. So looking in period 1, hydrogen and helium both only have 1 electron shell. Moving down to period 2, lithium and beryllium have 2 electron shells. And if we cross over this gap here, boron, carbon, nitrogen, oxygen, fluorine, and neon are going to have 2 electron shells. And the same goes for the elements in period 3. They have 3 electron shells. And 4, they have 4 electron shells, and so on all the way down. And so this is going to be true of the Bohr model of the atom. So again, like we said in our last video, things are a little bit different with the electron cloud model or the quantum model. So with the Bohr model of the atom, this pattern is going to be true. So now that we have seen the atom and got a good description of the atom and its electrons, we are now ready to start talking about molecules and some basics of chemical bonding. So we'll see you in the next video talking about molecules. See you there. If you learned something from this video, please give a like and subscribe. We're going to be coming out with more videos soon. See you there.